What if I told you the powerful GPU driving your latest AI project or rendering complex designs might be harboring a silent, microscopic vulnerability, one that could flip bits of data and compromise everything you are working on? It is not a software glitch, but something far more fundamental, etched directly into the silicon. NVIDIA, a company synonymous with cutting-edge graphics and AI, recently issued a crucial warning to its users. They are reinforcing the recommendation to activate something called System-Level Error-Correcting Code, or ECC, on many of their professional GPUs equipped with GDDR6 memory. Why? To defend against a rather insidious threat known as a Rowhammer attack. Now you might be wondering, what exactly is Rowhammer? Imagine your computer's memory, whether it is RAM or the dedicated memory on your graphics card, as a vast grid of tiny, delicate cells, each holding a single bit of data. These cells are packed incredibly close together. A Rowhammer attack works by rapidly and repeatedly accessing one specific row of these memory cells. Think of it like vibrating one string on a guitar so intensely that it causes an adjacent string to subtly hum along or even change its tune. This rapid hammering of one memory row can literally cause the data in an adjacent row to flip its bit. A 1 becomes a 0, or a 0 becomes a 1. This seemingly minor change can have significant consequences, leading to anything from a simple denial of service, where your system just crashes, to corrupted data, or even a complete privilege escalation, giving an attacker control they shouldn't have. Historically, we have seen Rowhammer demonstrated on standard computer RAM, or DDR memory. But new research is showing that this attack is very much possible on the GDDR6 memory found in many powerful GPUs. Researchers at the University of Toronto developed a method they call GPU hammer, and they successfully demonstrated it on an NVIDIA A6000 GPU that did not have system-level ECC enabled. They showed that even though GDDR6 memory is generally harder to hammer due to its higher latency and faster refresh rates compared to the DDR4 in your CPU, these attacks are indeed possible on your GPU memory banks. So what is the defense? That is where system-level error-correcting codes, or ECC, come in. When you enable ECC, your GPU's memory doesn't just store your data, it adds extra, redundant bits. These bits act like a built-in detective, constantly checking the integrity of your data. If a single bit flips accidentally, or due to a Rowhammer attack, ECC detects it and corrects the error on the fly, preserving the accuracy and reliability of your information. For anyone working with large datasets, precise calculations, or complex AI workloads on workstation and data center GPUs, having ECC enabled is absolutely critical to prevent those crucial errors from creeping into your work. NVIDIA recommends activating ECC for a wide range of its professional data center and workstation GPUs, encompassing many models from their Ampere, Ada, Hopper, and Turing series. However, it is worth noting that some of their newer GPUs, like certain Blackwell and Hopper data center cards, already come with built-in on-die ECC protection, which means you do not need to do anything extra. If you are using one of these powerful GPUs, you are probably wondering how to check if ECC is enabled. One straightforward way is to use NVIDIA's command line utility, vigorously, right from your system's CPU. It allows you to quickly check and enable ECC where your card supports it. For more enterprise-level environments, out-of-band methods using tools like the Redfish API can provide that ECC status information. While Rowhammer represents a genuine security concern, especially in multi-tenant cloud environments where numerous users might share vulnerable GPUs, the real risk depends on the context. Exploiting Rowhammer reliably is complex. It requires specific conditions, extremely high access rates, and precise control over memory, making it a challenging attack to pull off successfully. So, while the threat exists, enabling ECC is a proactive step you can take to safeguard your valuable data and calculations. It is a reminder that in the world of tech, the security game is a constant evolution, even down to the very bits in your silicon. Have you checked your GPU's ECC status lately? Let us know your thoughts on this fundamental layer of hardware security. You can find more details and instructions in the show notes for this episode.